term. This is a k squared times E field, right? This is what we already obtained. And for this part, maybe you will have a little question. What happens if we take twice the curl operator? We take twice. You use the vector identity from the appendix. You will find if there is a double curl of the vector A, or maybe in our case it is a vector E, will become these two terms. Okay? And it is good that we know this equation and we know this part is 0. So we can just replace this term to only this term, right? 5 points question. What is this? Anyone? Maybe we wait. If there's no one want to answer, I will give you the opportunity because you already have an extra point. Anyone? What is this one? Can not yet. What is that? Think about it. What is gradient? Gradient is, this is gradient, right? What is, this is a square, right? What is this? Anyone? Close. Okay. We have a special name for this. Special name. Do you have anyone? Raise your hand. Raise your hand, please. Come on. 5 points. Did you answer already? No. Someone else. I give other people opportunity. Anyone? Do you want to answer? No? What is that?
Double. Twice.
Huh?
Partial twice. Twice.
Do you have the PowerPoint for my last class? No? Yeah. All my questions are easy. If you pay attention and you understand, you are supposed to answer. Why do you want to check my PowerPoint? Anyone? 5 points. Raise your hand and tell me the answer confidently. No? Do you want me to show you the answer? Okay. You want to write down? Okay, it's okay. No, not the question. The name. Yeah. How we call that? They have a special name. Maybe I know you will not need, you are checking the answer from my PowerPoint. I'm talking about what is the name of that. I already told you, but you didn't pay attention. What's that? Okay, everyone can answer.
Dale.
Raise your hand. What?
Dale.
Huh?
Dale.
D-E-L. There is a name start with L. The first letter is L.
Laplacian.
Laplacian. Okay. 5 more extra 5. Because you are listening. Laplace. Laplace. Do you remember? Do you remember? Okay, let me remind you that is in my first PowerPoint. Laplacian operators, the answer was already there 2 weeks ago. When I tell you what is that? Right? If you take the Laplacian to a scalar function, the answer is also still a scalar function. If you took the Laplacian to a vector, the answer is still a vector. So what we are taking? We take the Laplacian to a vector. So we will have another vector for that. Okay? This is just a name. The name. But how do we calculate? So that's why people say, oh, I take a 2 partial differential. This is how we do that. And this is, my question is, what is the name? Right? Then how do we do that? We do this one. Okay? This is exactly what we do for this equation plus k squared times E. Okay? To simplify this question, we don't want to scare any of you. So we try to, this is Laplacian operator. Actually, I put that on the, also on it. So I try to simplify the questions. I want to make it as simple as possible. So how do I make the question as simple as possible? I try to just assume my E field has only one direction. And this E field can only change by this direction. Okay? This is the simplest way to try to answer this question. I need a very, very simple way. So what if there is a field has only one direction and this field can only change, the magnitude of this field can only change according to this direction. This is, we are trying to understand what is the simplest E field. We call that the plane wave. Because I have the field has only the same, they have the same property probably on the XY plane. Everything is totally the same on the XY plane. But this field is changing if you change Z. Okay? We call this plane wave. What is plane wave exactly? If we have a current source and we try to observe the field from the charge source, we try to observe that in a very far away distance. We try to see what happened there because we are very far away from the source. Like if our Earth is very huge, you feel like the ground is flat, right? Because the Earth is too huge. Very similar here. If I am far from the source, the charge source, I will feel like the E field from that is a plane. So this is a plane wave. Okay? This is the simplest way to understand what is the E field. So this is actually we try to, you remember these figures, right? They are what we trying to explain the vectors that happen if this happened, this one only change in z direction. Where is z? X, Y, Z. Z is up and down. So only z change, the color will change. The direction will not change, the value, the magnitude will not change. So this is A equals to something. Okay. It's very similar to what I tried to tell you. Plane wave, everything's the same. Okay. So come back here. So this is the general form. If we consider not only x, y, z, but also time. So our EX, it is a function of the magnitude of your E field in x direction. This is only in x direction. We consider not only x, y, z, but also t will look like this one. And the general form you need to consider in the real world. There is not only x, but also y and the z axis, right? So this is the most general form for the E field. But because we are not that smart, so we try to simplify the question to a simple question. We consider only the x direction, but this is a plane wave. The wave will not change according to x and y. Or in my PowerPoint, if I use the green, means 0, okay? There's no x and no y. So this is only an equation relevant to z and t, time and only the z direction. Our wave will change according different z and according different time. Okay, so this is the simplest way we understand it. And we put this equation of why can this become 0? Because they don't have the variables about x and y. So anything when you take partial respect to x or respect to y, the result becomes also 0. So this part can become this part. Okay? Are we good? This part is this part. And I remain this, I change this one to only, because this is just only the k squared times the vector. So they are the same. So we can solve this equation. It is just a simple, what's that? PDE, the second order of partial differential equations. Have you ever learned that from calculus? So this is unknown. This is unknown. And we try to solve E field. You take the second order of the partial differential equations, and this one plus k squared equals to 0. Okay, I feel like someone feel nervous, but don't worry about it. We got the answer for that. If we solve that equation, our result is some magnitude times exponential to the minus jkz plus e minus times exponential jkz. If our equation there has no time, if we just neglect the time component, we try to solve only for the x, if you have only unknown x, okay? So this is the answer I asked you about what is the E field looks like. I my experience is you feel nervous now because there are many unknown notations, but you just need to get used to it. You need to know the magnitude, or you can say if that is a voltage, is an amplitude, how big it is. How big it is. This is the E plus. This is just an unknown. Don't worry about it. This is just an unknown. Like A. Okay? This is unknown. Okay? Times exponential minus j k z. This is the form. The solution of this equation has another part, another magnitude times exponential plus j k z. Okay? J is j squared equals to minus 1. This is the I we learn for a complex. Okay? Well, we usually use j, that's the same as I. I squared equals minus 1. Okay? So, for this two terms, K is this K aside. Z is the position. Because the only thing change is according to Z. Our EX will change only with Z. So, this equation. Okay? If this still borrowing you, you still feel like too hard, too many unknowns. It's okay. I try to explain that. Maybe we already introduced this before. If there is a complex plane, there is a real axis and an imaginary axis. You have some value here. The value is A. If A is a complex value, you remember? Then you can write down like A equals to the magnitude of A times exponential j theta. Or this is also cosine theta times the absolute value of A plus, I should have more space, j times A times size. I need more space. Do it again. I try to explain this part to you. This part. We can see this like a exponential j something, okay? This is exponential j something times some value. This is our E plus, the same, just name, just different name, but the same thing, just something, the magnitude, how big it is, okay? And we put that on the complex plane. You can change this because this is what is the absolute value of it, and to the theta here, and you can regard this is a real, and this is an imaginary. This is a cosine of the A plus j sine. This term plus this term. This is a real, this is an imaginary. I hope I explained well. But this, you can use the Euler formula. You can change this one, and if you want to solve the equation, you just see what is the real part of it. So the result will become the magnitude E plus times cosine something plus E minus cosine something. What happens if J omega t come back? Because we neglected the time component, so we try to multiply this part E to the power J omega t back. So the total thing here is it is the epsilon E of the function Z and T. Okay. Why we times this one here? It's okay. We discussed this very beginning, right? There's when we discuss why partial T become J omega, I try to tell you it is because all the time component it is exponential of J omega T. So we divide this by time, we'll left only J omega. Remember this one, right? So this is that part, exponential J omega T. So yeah, we got the answer I asked you. So what is the wave looks like? It is something times the cosine of omega t minus kz and something times cosine omega t plus kz. What are they? They are two different waves to the positive z and the negative z. If you solve this equation, you find out there are two directions of the E field. One to the positive z, another one to the negative z. Okay? Question? So this is our result, and then maybe you will need more time to check what is that. Something maybe we will use is this. What is this? Actually, what is this? What is the result we obtained so far? Too far? The derivation may be too far from you to understand. Okay. I have Maxwell's equations. If there is no source, I try to solve what is the E field. Okay? I solve E field. And the E field become two fields. One to the positive Z direction. Another to the negative. Okay? Okay? For this term, I can see that is something times cosine omega t minus kz. And this term is E plus cosine omega t plus kz. They are two cosine functions, have the different magnitude. We haven't solved the magnitude yet, but we know it is a function of cosine. This is what we already learned. Okay? The E field is a function of cosine. And this is important. This is omega t minus kz, or omega t plus kz. We hear that a lot. Maybe when you are designing a circuit, if you try to design circuit, you will hear phase, right? You will hear theta, right? You hear that before, right? Phase, theta. That is Okay? For the positive wave, the phase is omega t minus kz. Okay. Maybe I have questions. Anyone want to answer question? Okay, I will start from you because you are very behind. Yeah, you should. Okay, try to answer my question. Okay, if you okay, if you correct, maybe I will give you some money. All right. About this term, the phase of the positive wave. Tell me what is omega. I want to ask you everything from it. What is omega? What is omega? Tell me. So you don't know what is omega and then you are sitting in class for 3 weeks? That's not responsible. Xu Fuyao, what is omega? Huh? Similar but close but not right. Where can you get it? What is the beginning of omega? Why we have the result of omega? Where did you find it? What is the original? Did you follow me from the beginning? Huh? Yeah. Yes. 2 pi f. This is the angular frequency, right? 2 pi times frequency. So we are talking about a wave. What is the frequency of the wave? More. So what is t? T is time. Yeah, good. What is the z? What is z? You are close to get 5 points, Neojin. Z is yeah, the y is xyz. It's the space, right? The position. What is k? Do we have a definition of k? Do you know the name of k? What is the k? If you are correct k, I'll give you 5 points. K. Yeah. Okay. So what is the equation of k? Okay. You both of you get 2.5. Okay. Not bad. K is the square root of omega times mu epsilon, right? We try to solve it from if we times this one to this one, we got it. I said this is ugly, remember? So I don't use that. So look at this. Something interesting here. Phase is a result of time and space. Do you have go to see a Marvel movie, the Thanos? You have a time stone, you have a space stone, right? Different thing, time and space, they are different things. But both of them have some contribution to phase. If you have a wave, it's changing after some time. So your wave will change. And according to different position, the space, your phase is also changing. You times your time to omega, which is an angular frequency. You times your z to the k. We know k is the phase constant. If your k is different, your wave has a different phase, different position. How can I say that? Your contribution to the space will changing according to your k. Okay? Your contribution to the phase will change according to t times 2 pi f. Your frequency is different, your time different, the result is different. This is very important. Many people don't understand about what is phase. This is where the phase comes from. This is only for the positive wave. It's omega t minus kz, okay? This is the phase. If you ever hear a phase, maybe you try to measure your circuit, the same. But you use voltage and current, the same, omega t minus kz. But when you measure a circuit, you will use the beta sometimes. Okay? So beta and the k are very close, very similar. In some cases, they are the same. Okay? So, yeah, this is a thing I try to explain what is the exponential j something. It is the real part is times cosine, the imaginary part is times sine. We think about the real part, and also this one become the phasor form. Okay, just some review. I write down, maybe it's not very good handwriting, but you also have my PowerPoint. So the result become, in the time domain case, will become this one as the result. We know our wave, the velocity of our wave in the air is the speed of light, right? Do you know that? Have you ever heard that? Do you have any idea how fast our wave is? If our E or H field is in the air, the speed of our field is c. It is 3 times 10 to the power 8. Is the speed of light. This is and then this one equals to frequency times the wavelength. You have ever heard this from the physics class when you are freshman? Yes, it's very basic. This is a basic. But what happens if our wave is in some material, not air? What is the speed of the wave? You can consider this one. You will have already have the distance. This is the phase, right? How do you define speed? How do you define speed? How fast it is, right? But we are talking about wave. How do you define? You need to, okay, let me try to don't have enough space. We define, the way we define the speed of our wave is, we want to think how fast this is, right? We need to fix some point. And we try to know, this is z direction. We know, okay, start. Okay, I give you maybe 10 seconds. Oh, stop. start and stop. And then after that, this wave goes to another place, to another z, right? So we divide delta z to delta t, and this is like a speed. This is how we define speed. We need to divide the difference of the space to the difference of time. This is the velocity, okay? So after we have that, we want to, do you have this idea that if you take the partial differential to the t equals to 0, what does that mean? Anyone want to tell me? What does that mean? This one equals to 0. Any idea from your calculator class?
Constant.
Raise your hand, please. I want to know. Okay, Yo Jun, you want to more point? You take it equal 0 means
T is constant.
t is a,
And the phase is constant.
the phase is constant. Yes, it's very similar to that. Okay, I'll give you. Now you earn 5 points. Because these are the maximum or minimum value, right? You remember that from the calculator class. So you take this one equals to 0, which means this equation can change to this term. And this is dz, partial z, partial t, or dz dt. It is the definition of velocity, right? So you can change that to our velocity equals to this one, and from this relationship, Vp will equals to omega over k. Okay? Because this equation, this part is Vp, you take this one equals to 0, right? Only this term has the component of t. So we remain this part. Okay? And this one is Vp. So you can have a relationship of this one equals to, this is what we are trying to Vp will equals to omega over k. So the phase velocity will equals to omega over k according to this transformation. Okay? Do you need more time for that? Maybe you can check it in your textbook. They say totally the same thing, okay? I just try to explain in my way. So, how fast it is? It is 2 pi f over k, omega over k. And as you told me, k is omega times square root of mu epsilon, right? This is the where the k star will equal 1 over square root of mu epsilon. What's that? If you try to answer question number 3, right? You put epsilon 0, and then take a square root of it. You will equal the speed of time, speed of light, 3 times 10 to the 8, 10 to the power. Okay, if you put mu is mu 0, epsilon is epsilon 0 for the air. If you put that, you will get our wave, the speed in the speed of our wave in the air is the same as speed of light. Okay? This is one of the way. This is your midterm. The question will show in your midterm. Of course, I will ask you how fast your wave is. This is one of the questions. After you derive the wave equation, you obtain the phase, right? After you know the phase, you can calculate the phase velocity, how fast it is. After that, actually I have more to tell you. These 2 pages are talking about what we can observe. As I said, there are 2 parts of the 2 parts. They can contribute the final phase. Not only space, but also time. Okay? If you put your t plus t here, this t is a cycle. What is a capital T? It's a cycle, which means how long, how many seconds you will take for your whole loop. This is a t, this is a time. This is a variable of t. The t here is the time. T is 1 over t equals your frequency. Okay? The definition of frequency is how, for 1 second, how many times. This is a frequency. What is a t? T means when you take 1 time, how long? It's a cycle. What is a cycle mean? Okay, so the capital T, 1 over capital T equals to F. You put the capital T here, you can obtain, if you change T, you have more T, the T is, you have 1 cycle T here. It's 2 pi. You put a phase equation here, the total, the result is 2 pi will equal omega times T equals 2 pi. And after that, omega is 2 pi F. Then you put a T here and you obtain F equals to 1 over T. This is our definition of T, of our cycle and the frequency. Okay? You put one more cycle of time here, a period, a full period of time here. You will obtain the result. Frequency, the definition of frequency is 1 over capital T. This is what happened. This is, if you repeat your T, means your phase has 2 pi. Okay? You got it or not? No? Your T, next T, the difference of your T is a capital T, is a cycle, a period. 一个周期, a period. Which means your phase is 2 pi. Okay? The same. If your cycle of if you repeat your distance to a lambda here, your space is repeated in a lambda here. You try to do a calculation, will equal 2 pi, you will get the result of your definition of lambda is Vp over F. This is Vp equal F times lambda. This is the wave not only in the air, but also in everywhere. This is the relationship of lambda equals to Vp over F. Okay? As I try to explain to you, phase is a result of time and the space. Not only time, but also space. Not only space, but also time, actually. Actually, you always consider space, but they will change according to time. This is a result. Okay? If you see the oscillators, you will see the voltage and the wave from it. This is time. It's changing. This is what actually it is. It's in a scale. The vector, if your x direction is time, This is what happened of the wave. But this is the voltage, right? We are talking about the E field and H field, they are the same. They are also cosine. Okay? And moreover, we don't have enough time. This is why we are showing to you, but probably I will start here next week. This is, I will give you some time to answer a question, and we try to help people to understand more. If you have a voltage and a current, you want to try to understand the relationship, which is V equals to IR, right? This is the resistance, voltage and current. Also, we have the relationship about E field and the H field. They show up together. We want to know the ratio between E and the H. Not here. From here, you think, too hard, you have something different. But can we try to solve the ratio between E and the H? This is what we are trying to do. We exactly put E field on the curve operators here, and we try to solve the ratio between E and the H. That is the impedance. That is wave impedance. What is the ratio? Do you know ratio? Ratio. R-A-T-I-O. V, yes. V over I equals to R. R is the ratio of V over I, right? We want to know what is the ratio between E over H. This is wave impedance. This is we are trying to learn. This is the next time. Okay, I will give you some time to finish the questions. If you have time, we will start the answer question at 5:30. Okay. Anyone haven't finished the question yet? Or all of you already finished it? Okay, we'll take a break. We will check the answer at 5:30. Okay, next class.